All right, question number 2. We want to give the three conditions that must be satisfied by a function to be continuous at a point. So from the definition, we were told f of x, the limit of f of x has to exist. F of a has to be defined at this point a, and the limit of f of x has to be equal to f of a. All three of those need to be satisfied to be continuous. All right, question number 3. We want to determine the points on the interval 0, 4 at which the graph of f has a discontinuity, and then at each point we're going to state the conditions that are violated, so the previous definition. Now, upon looking at this, you would probably want to say, because there's a hole right here, you would say it's discontinuous at 0, also at 1, at 2, at 3, and maybe 4. Like you would maybe pick all of those. However, when you're approaching this, you want to think about that very informal definition. Can you draw the graph without picking up your pencil? So if you start like there's a hole, and so you would just kind of like not really touch the line, but you can draw this piece, and then you'd have to pick up your pencil because there's a hole and come on the other side. So this piece, the first discontinuity comes right here when we're at 1. And then we go here to the next piece, and then there's another hole, so that would be the next discontinuity would be at 2. And then we would drop all the way down, and we would end at an end point, but then the graph breaks. So then I got to pick up my pen again, and then I can draw the next curve. So there's 1, 2, and then this happens at 3. These are my 3 points of discontinuity. So we will say x is discontinuous at 1, 2, and 3. All right, so the points that violate the first condition, this is the first one we're looking at, the first condition. First condition says f of a is defined. So of those points, 1, 2, and 3, 2 has a solid dot in line with 2, and so does 3. Number 1 does not. So number 1 will violate the condition that f of a is defined. There's no solid point on this line, x equals 1. The points that violate the second condition, so the limit of f of x exists. So we talked about limits. The left and the right hand side of the graph have to be approaching the same y value, and that is true for every point except 3. Approaching 3 from the right, we're going toward a y value of 1. Approaching 3 from the left, we end up at a y value of 2. So because these two go to different points, the limit doesn't exist, and that happens when x is equal to 3. So when x is equal to 3, violates condition 2. And then the last one wants to know what points violate condition 3. That the limit of f of x as x goes to a is also equal to f of a, and that would be x equals 1, 2. So we do get a limit. Both sides are approaching, this would be 4. So as x approaches 2 from the left and right, we're going to 4. However, the value of the function is actually equal to 5. So x value of 2 breaks the condition 3.